Today we 3D print a marking gauge. The combination square is one of the most used items in my shop. I mainly use it to measure and to mark a distance from the edge. Over time, we accumulated quite a few of those combination squares in the shop. However, I am using them as a kind of story stick. That means I have one of them set to the distance of a mark from the edge, the other one to the depth, and so on. When you try to keep the important measures of a project all locked in place, you are quickly running out of combination squares. While combination squares are quite expensive, these stainless steel rulers retail at €4 for a pack of 3, shipping included. Wouldn't it be great to have a marking gauge or combination square replacement for less than $2? The final result has a small lever to securely lock the position with one hand. You can use it for measuring as well as for marking. Creating such a tool is super easy, at least in theory. You just need a steel ruler, a nail, and a 3D printer. First, you have to measure the diameter of the nail, the width of the ruler, and the thickness of the ruler. All these dimensions should be measured quite precisely. Then go to my Thingiverse website, type the numbers in the customizer, and download a customized STL file for free. Send it to the printer, and in an hour or so you will have everything you need. Insert the steel ruler in the slot and make sure it slides freely. Use a thin needle to align the holes in the sides with the hole in the lever. Then, clip a nail to the width of the marking gauge and press fit it in the hole. After it touches the lever, you can drive it down with a hammer and the marking gauge is ready. That's the theory. But in practice it took me 9 tries in order to get the prototype right. Let me share my mistakes so you don't have to repeat them. Let's take a quick look at the design to understand why it is so tricky to get it right. I wanted to have an eccentric lever rather than a screw so that it would be easy to lock the position with one hand. In the side view, you can see very well how moving the lever is holding the ruler in place by friction. But the animation also shows you an indication how little margin of error we have in this construction. The first parameter is the width of the ruler. This parameter is critical. When the slot is too wide, the ruler will not be perpendicular to the workpiece. I found that adding 0.3 mm to the width results in a very snug fit on my CR10. Even with these settings, I had to press really hard or secure the ruler in a vise and give the print a few taps with a screwdriver handle. And here's a pro tip. If you break the screwdriver handle by pounding on the print, the fit might be a bit too snug. For the thickness of the ruler, I add the same amount of play and increase it from 0.6 to 0.9 mm. If there's too little play, the ruler will catch layers from the print in the opening and damage the print. The last parameter is the diameter of the nail. There I only add around 0.15 mm allowance. If the print needs super glue in order to hold the nail in place, the tolerances for the lever are most likely not going to work out, so you can directly aim for a press fit. If you stick the nail through the hole, make sure it slides through the side part without problems before tapping it with a hammer. Without support, the side part is going to break if you hit it with a hammer. If you take all this into account, you get a print that slides easily across the ruler and is securely locked in place once the lever is pushed down. If you enjoyed the video, please consider subscribing and have a look at other videos about using the 3D printer in the woodshop. Thanks for watching.